Hello and welcome back. So in the last video, before we ended the discussion or the lesson on the printk function, I mentioned to you that the downside of the printk function is the fact that it is an in-place logging technique. And what that means, as I said, is that it's practically blocking your processor from doing anything else until all the bytes you have decided to write is actually written completely. And so, in time critical firmware solutions, you want to stay away from the printk function, or you want to be careful how you use it because it blocks the thread until it is completely done. Now in this video, as I promised, we are going to look at a more feature-rich login solution that Zephyr ships, and the name is the Logger module. So on your screen, I have already prepared some code, and I'm going to explain the code line by line. We start with line 1. You can see that I'm including Zephyr /login/log.h. It's not like the printk where I included Zephyr /sys/printk.h. So this is an entirely separate module. On line 4, I am registering my module. Don't get confused here. The logger itself is a module, is a solution that ships with Zephyr. Now you need to register your module, and once you begin to see the output, you will understand why. The module here, just think of it as the file in which you are actually going to log out some messages. It helps you when it comes to filtering so that you can filter out that, okay, I want to see all the log messages that are coming from, let's say your project is big, you have a part that handles audio processing, and there is a part that handles timers and stuff, right? So you want to register each module before you use the log functions in those modules, and this is how you will be able to filter out logs or log messages that you wrote from specific files in your project, right? So you need to register that, and you use a function. It's actually a macro called log module register. And remember, I'm saying main here because the name of my function is main, but it doesn't have to be main. I could put anything there. One key thing you need to take notice of is that it doesn't have to be in quotes, right? Just write it out as it is. These are some of the magic that happens with Zephyr. So it's not a string, but you can write out anything that you want. And then this also has what is known as log levels. The levels determine the severity of that particular situation that is calling for the log. The highest log level, of course, as you might already know, is log level error. An error is something that happens that should cause the firmware to probably stop running for the sake of safety. Okay, let's say I'm trying to come up with a hypothetical example here. Let's say you are working on a firmware for a delivery drone, right? And then for some reason, the drone isn't able to establish GPS connections to know where it currently is at the moment. Then it probably makes sense to let the drone return back to base without delivering, because you might end up delivering something to the wrong recipient, which could have different effect afterwards. And so if anything happens and for this reason the firmware shouldn't run, it's an error. And so you log with level error. But on line 4, we are registering our module and we are telling it the highest level of logs we are interested in seeing. So this is part of the filtering that I told you about. So in this same file, we can log, sorry, the lowest level of error that of log that we want to see. So in this same file, we could log levels that are higher, but it won't show. That's basically what the filtering is helping us to do. So the highest log level is error. The next is a warning. So a warning is something that definitely deserves your attention and probably deserves some engineering work to be done to fix, but shouldn't prevent the firmware from running if it's running okay. Info is the next, and that's basically to show some information. And there's also debug. These are informations that you're only interested in when you are debugging, right? So these things, you pick them up as you use the solution. Now, every other thing that you have learned from printk works. So I can actually declare variables, and I'll show you. I can declare variables and also include them with format specifiers, and that is going to work as well. So line 4 is how we register, and you will see why this registering is important when you see the output. This is how you log an error. You just say log error, and then you give it your message. If there are variables you want to see, then you use format specifiers like %d, %f, %x, %c, and all those format specifiers in C, and then you bring the variable afterwards. Log 1 is for warning messages. So it's your firmware, right? You know what is an error, you know what's a warning, you know what's informational, you know what's debug. So you choose what is right for your particular use case. But the function names is just log, and then the log level follows. And then a very cool thing about this is also it has what is known as a hex dump. So it basically dumps out, it writes out the content of a particular block of memory that you give it in hex, and you can see that. Okay, so you can see that on line 12 I have declared an integer array I call buffer, and I've stored 1, 2, 3, 4, and 5. I just wrote it in hexadecimal, but I didn't have to do that anyway. And then I call log hex dump inf. So I'm logging it as info. I could log it as an error, I could log it as a warning, I could log it as an info or debug. It depends on what 3-letter words I put here, right? And what it takes, first of all, is the address to the memory where you want to log from. And because this is an array, and the variable of an array is actually a pointer to the memory location of the array, so I don't need to put the ampersand there. It's already a pointer. You have to tell it the size of bytes that it has to print. It has to read starting from this address that you've given it. And because I want it to print everything, I say the size of buffer. And because the size of buffer is 1, 2, 3, 4, 5, it's going to print 5 in 32 values starting from this address. And this is any maybe we should see the function signature. So you can see that it takes data, length, and then a string. So it's any string that I want to use to describe the login that I have done. Now I'm going to surprise you. We will compile this code, we will upload, and it's not going to work. It's intentional, and I'm doing this so that you will never forget it. Okay, so this has compiled, and you can see that in here I have added config uart console is equal to y. I'm going to explain why. You know, this logger module is feature rich. It can let you even choose the technology that you should use to send to your host computer. For example, on my board I'm using uart. That's why I'm saying config uart console is equal to y. I didn't have to do that for printk, and I actually don't have to do that here also. It's the default. But if you are using any of the Sega boards, they have J-Link, and they have what is known as RTT. It's a real-time tracing solution that helps you to trace some of these debug information in real time, and it comes with a special hardware, so you can configure that to work with any of the Sega J-Link solutions as well. So it has different backends to it basically. Now I'm going to upload this code to the board. code is uploaded. I come to my serial monitor. Let me clear screen so we start afresh, and I'm going to press the reset button, and I'm pressing it, but you can see that what we have logged out is not, being sent to the UART console, regardless of me saying config UART console is equal to true. And the reason is that for you to enable this config module, you actually have to say config log is equal to y. This is what enables the module itself. Before anything else you do is going to work. So now let's compile again. So what I don't want you to forget is to include config log equals y in your project config file. So project is compiling, it's done. Let's upload it to the board. It's uploaded, and now we can see the output. Now let me go to the code so we appreciate what this module does for us. This is error occurred. Where is it coming from? It's coming from line 7, error occurred. So you can see that what I typed here is being shown verbatim, error occurred. But look at it. It is showing it in a different color, right? You don't get this with printk. It is showing this in a different color so that once I see red, I know some error is happening in my firmware. And like I said, errors are situation that calls for you most likely stopping the firmware from running and doing some engineering work to fix. So an error occurred, it's in red, and the module name that I chose, main, is here, right? If I had done something like I don't care, I can write this, compile this. I think compilation is done, and run it. So you see that when I change the module name to I don't care, it's also stating I don't care as the module name here. So like I told you, it's just something to describe the file from which these logs are originating, so that it's going to help you to filter them out later. If you say I'm only interested in log messages that is coming from this particular file, because by the nature of what you're observing as the issue with your firmware, you can tell where in your source code that problem is coming from. So it's purely for filtering, right? So you choose what you want, right? Now, the next one is warning, and you can see that warnings are logged in yellow. On the left, you can see that there is also some timing information here. The reason why they are all showing as 00000 is because, all I'm doing in this code is to log, and they are fast enough that they are not actually taking any time. But what Zephyr does here is it counts the tick count, like the number of cycles that have gone by since your firmware started running, and it's going to convert that into a time. The good news is that if your hardware has a real-time clock also, Zephyr, and here I want you to read the Zephyr documentation on login to see how to do that, but it has the solution where you can actually configure so that the date and time is going to come from a real-time clock. So imagine you have a product you've put in the wild and you want to see what's happening moment by moment, then that becomes very, very important. So the time information also helps you to know, okay, at which point in time, maybe there is a bug in your firmware that is seasonal. It happens based on time, right? Then this information is going to help you. So if you go through your logs, maybe this is a solution you've built and you've put in a forest to track some animals, and then you later go for it to read some log information. Maybe you're not logging it over the internet, so you manually go for it to read some log information. This time information is going to help you to identify patterns of seasonal situations or bugs that happens in your firmware. So this is super cool and it's fantastic. These are some of the advantages the logger module has over the simple printk, right? I'm going to tell you the greatest advantage at the end of this video. And we also have log info, which is white, and debug, which is also in white. It's informational, right? Now let's see the hex dump. I dumped the buffer that contains 0, 1, 2, 3, 4, and 5. And you can see that it has, printed it out in hex. And see, because it is a uint32 type, they each take what? 4 bytes. So my number one is taking 4 bytes. This is a byte. This is a byte. This is a byte. This is a byte. So 4 times 8 is what gives me 32. So each number you are seeing here is a nibble, right? It's 4 bits. The decimal or the hex version of the 4 bits is what is writing here. So 0, 1 is here. And then I have 2, 3, 4, 5. I mean, I didn't have to use uint32. If I change this to uint8, maybe it will help you to understand what I'm saying better. So let me just compile this again. And then I think compilation is done. I'm going to upload this to the board, and flashing is done. So I come here, and then you can see that it is using just, it's shorter. It's no more 4 bytes. This is just 1 byte because I said it is uint8. So there are a lot more you can do with this logger module, like filtering and then conditional compilation, where you can also say if you are in debug mode, then it should include this, otherwise it shouldn't include, and stuff like that. Now, the most important difference between the logger module and the printk is the fact that the logger module, when used, causes Zephyr to create a separate thread that handles flashing out these log messages, so it doesn't get intertwined with the timing situation of your firmware. It has a separate thread called log process thread func, I believe. Yeah, log process thread func. And this is a separate thread that is spun by Zephyr, and its work is to be checking. So every log message you write actually goes into a buffer, and when that buffer size is full, it flashes it out. So this doesn't get in the way of the timing of your firmware. And we will talk about threads later. I don't want to be ahead of myself to descend deeper into something I haven't taught you about, but just believe and accept that this is an advantage over printk. Thank you very much for watching this, and I will see you in the next.